So my topic is on broadband wireless access. We also call them as BWA. First I will start what is meant by broadband. See, the term broadband refers to the transmission speed. We all are used to access the internet, and this access should be at a faster speed, as fast as possible. So everybody likes, like, if I want to open my even mailbox, so I feel that just at the click of the mouse my inbox should be open, should be available to me. So it depends upon how fast I can access the internet. During my lecture I will be calling this internet as an information network, because accessing some information may not necessarily internet, it can be web, it can be our intranet, it can be the website of NITTTR. So I will be calling this network as information network. So the question arises that what are the various technologies by virtue of which we can access the information network at faster rate. For that purpose this broadband term has evolved. According to FCC, which is the international regulatory body, it says that if the uplink speed is around 200 kbps, then we shall be calling that technique as broadband. However, this 200 kbps uplink speed seems to be low. Anyways, it was defined FCC by so many years back, so we still stick to that. Otherwise, nowadays we call that if the transmission rate is on the order of 1.5 Mbps, then we shall be calling that technology as broadband. Two more words are also there in this topic, that is mobile and wireless. See, when I use mobile, it means that I am able to access the information network while on the move. So this is one feature of the access technique which makes it mobile. Okay. The second term is wireless. The word wireless refers to the interface. It is simple, like when we watch some TV program, I can control the channel by means of remote control. So here the interface between the remote control and the TV is wireless. So the term wireless refers to the interface, and the term mobile refers to the mobility, that is accessing the information while on the move. Now I will start with first slide. Wireless communication. As you all know that nowadays wireless communication has become an integral part of our life. It has changed the way we live, we network with the people, we talk to each other. Like when communication was going on with NITTTR, it was always online. So wireless has changed the social setup even. It is the field of explosive growth as far as demand is concerned. You may be knowing that mobile telephony users in India nowadays at present they are around 200 million. Internet access, there are around 42 million users out of 1129 million population of India. So out of this population 42 million people are using internet, and out of these 42 million, 28 million are active users. Active users means which frequently access the internet. And a very good figure is again given, that is 3.7% of our population is using the internet, and this constitutes the total 3.6% of world population which are using the internet. So I mean to say that in India the demand for mobile telephony and internet access is quite large. So we even expect that by next year March 2000 this figure will touch 54 million. So you can see how fast the graph is moving towards the demand as far as these two basic services are concerned. One is mobile telephony and another is internet access. I want to emphasize this fact because if demand is there, then you have to develop the technology, because technology development only takes place when demand is there. So we have enormous demand in this area. So let us see the development. Development of wireless communication, it is of course the motivation behind this development is the demand. I will not go into the Marconi era when radio was started. I will concentrate only on mobile and then broadband. So the cellular telephony started in 1990s. If you talk about GSM, because GSM global system for mobile communication has been the most popular standard till date. Prior to that, 1G was also there. 1G has NMT. It stands for first generation. And a very good example of is NMT, AMS, and so on. The peculiar feature of this first generation cellular standard is that they were based on analog communication, but people were not happy because capacity was less, quality was not so good. Then we came to 2G second generation. GSM is an example of 2G second generation system. It is based on a digital communication technique. So, all the advantages which are associated with digital communication, they all are available to the user in 2G. Then again, because 2G basically is voice centric, means we can only use it as a voice communication media, and we are not satisfied with only voice. So, we need data also. So, after that it was extended to 2.5G, and 2.5G is GSM, Global System for Mobile Communication. Then it was extended up to 2.5G, we call it as GPRS. The people who want to use the internet access on their mobile telephony, they have the mobile telephone which are GPRS enabled. So, later on again we find that no, 2.5G is not sufficient as far as the demand of the persons are concerned. So, then it was extended up to 3G, third generation cellular standards, which exemplifies like UMTS or IMT 2000. In India we have certain features of 3G, but it is not available till date as far as our country is concerned, but in developed countries 3G features, 3G services are available. Here I want to emphasize that the applications provided by these 1G, 2G and 3G, means different generations of the cellular standards, they are basically meant for voice communication with some flavor of data communication. So, this revolution started in 1990s. After that, second revolution came 2000 year onwards, and we call it as Wi-Fi. I think all of you are aware of this Wi-Fi. Wi-Fi stands for wireless fidelity. It is basically an alliance. It has a number of technologies, we call them as family members, and out of those family members 802.11x is one family member of this alliance. So, it is just a forum. So, it standardizes the products. So, Wi-Fi is the second revolution as far as access to the information network is concerned. Now, still Wi-Fi has a number of limitations, as you know, and I will also discuss about those. Then there is a need of third revolution, and now we are moving towards this third revolution, and the major motivation for this third revolution is BWA, Broadband Wireless Access, which is the focus of my talk today, and this is under evolution. This third revolution has not come as yet, it is under evolution. Once this BWA is available, I can say that our society will become a mobile information society. Let us see what are the different drivers for this evolution, for this mobile information society. Prior to I explore the drivers for this BWA technology, let us see nowadays a common user, what does he want as far as communication services are concerned. It is not strange to say that the first requirement of any common user is telephony, and in telephony also it is not fixed PSTN, public switch telephone network. He needs the telephony while on the move. I mean to say that he needs mobile phone rather than landline phone. Again, I would like to give one figure that in the month of June 2007, in India 7 million users were added as far as the mobile network is concerned. And interestingly, some of you might be working in R&D. So, here there is a phenomena that this demand now is more from the rural areas. So, you have to concentrate on the technology which can feed the users from rural areas, because the next demand is from rural areas. The reasons are simple: tariffs are decreasing. Nowadays, you see there are so many advertisements and they talk of free calls among users, 30 paisa, 50 paisa and so on. So, the major motivation for using this service is low tariffs. Handsets are even quite cheap. We expect that by the year 2011, mobile telephony users will be 462 million. So, if you are working in particular area, or if you want to open an enterprise in this area, certainly you are bound to be successful, because the users are bound to increase exponentially. The second demand as far as communication services are concerned, that is for again internet access. And this internet access is not, I do not like to go to the computer lab to have the internet access. If I am sitting in my room, I want that it should be available at my desktop, or even if I am in the lawn having the gossips with my friends, even then I want the internet access at that point. I mean to say that internet access should be ubiquitous. The term ubiquitous refers to whenever, wherever I am, the internet should be available to me. So, he needs the internet access, ubiquitous in nature, and speed should be as fast as possible. That I have already told you that he is interested in broadband access, he needs the faster access. Again, for your knowledge, in India nowadays we are having around 180 operational ISPs. ISPs means internet service providers, and even then we are not happy as far as internet access is concerned. So, in spite of 180 ISPs. Nowadays there is one more term, we call them as quadruple play services. This is related again to the requirements of the users. See, the basic requirement of the communication lies in voice, then video, data, and if you add the term mobility, then we call them as quadruple play services. This is the terminology which the people working in this area use. Previous to this, we have triple play services also, and the triple play services refers to this is audio, or you can say voice, then data and video. So, if all these three services you require out of a network, then we call this as triple play service. But if user says no, I also need these applications while on the move, then mobility is also added, then we call it as quadruple play services. So, you have to keep in mind that if you are going to design a network or to invent a network, it should meet the requirements of this quadruple play service. Requirements, I am again repeating that any technology which can provide, which can meet the demand, these two particular demands of the user, it should provide the high data transfer rate and it must support the mobility. Now, the question arises that which technology can meet these requirements. Prior to that, let us see what are the technologies available and what are their weakness and strengths, so that we can overcome those limitations and then evolve a new technology. So, I am starting with the wireline data networks. The meaning of wireline data network is simply that it can have the high bandwidth data communication. All the electronics and computer engineering students, you know that there is a relationship between bandwidth and data transfer rate, that is B is equal to C log to 1 plus S by N. So, if bandwidth is more, then the data transfer rate can be more, though it is limited by SNR also, but it gives some indication as far as data transfer rate is concerned and bandwidth is concerned. The most prevailing technology as far as wireline data network is concerned is DSL. DSL, I think you must have read about DSL. This stands for digital subscriber line, and the idea is quite simple in this. This technology is being used by a number of subscribers. digital subscriber line. Here we have different versions, so that is why I have put here XDSL, ADSL, VDSL and SDSL and so many. The idea is that when we do provide the landline telephone up to our houses, so there is a wire extending up to the handset. The bandwidth which can be supported by this wire is much more than we are using. We are using just 4 kilohertz band, and then we sample it at the 8 kilohertz, and this is how it comes out to be 64 kbps. So, the idea is that if you have the pipe at your home, let us utilize the entire capacity of this pipe which is reaching to your home, and that can be obtained by using this pipe in digital domain, that is digital subscriber line. Our basic PSTN, basic telephony, works in analog domain, but if you can use the same pipe in digital domain, it can provide enormous bandwidth, and this is what DSL provides to us, and it is being used, no doubt. Here I have written here the copper telephone lines we can use to provide high speed data. There are different technologies available like ADSL, SDSL, VADSL, and then nowadays we are moving towards ADSL 2++. It can provide the downlink speed up to 12 Mbps. So, no other technology is near about that, and the distance it can provide this bandwidth up to 5.4 kilometer. However, you know that copper line has some attenuation with respect to distance. So, as the distance is more from the exchange, then the data transfer speed will come down, but up to 5.4 kilometer you can have very good speed if you want to access your information network. Again, for data we can have that there are 1.5 million ADSL subscribers, asynchronous digital subscriber. Asynchronous is wonderful because see, most of the time we download the things rather than upload, so it is better if the technology can provide higher speed for the downlink. In addition to this DSL, we have some more technology, OFC and T1, but the limitation of the wireline data network is that it does not provide mobility. So, this quadruple play service is not met. So, as far as mobility is concerned, we cannot depend upon the wireline data network. Secondly, it is associated with infrastructural costs also. That if you want to provide a single phone, then you have to lay down the wire and so on, and that in nowadays when the civilization is moving at such faster rate, it is not easy to dig and then lay down the cable and all those. So, the question is that we can have the higher bandwidth, higher data communication rate with the help of wireline networks, but we lack the mobility. So, ultimately we have to go to the wireless networks. Let us come to the wireless data networks. Wireless data networks, as you all know, they are classified according to the coverage area, and among them the most prominent one is wireless local area network. In this wireless local area network, the most mature standard is Wi-Fi Alliance. It is the most widely deployed wireless technology, and the family is IEEE 802.11x. Another is HyperLAN also. It has some contention difference or access techniques are different between HyperLAN and 802.11 family. It can provide the wireless access in areas with cell radius up to 100 meter. So, it is a typical value, because nowadays there are so many manufacturers who are giving the access points with different sensitivity and antenna. So, depending upon, if you talk about Cisco switch, then Cisco switch is sold at the price of rupees 40,000 and so. So, it has better sensitivity, it can cover larger area. If you go for D-Link access point, then D-Link access point can be had in 3,000 rupees, but it has its own limitation. So, idea is that yes, it can provide, depending upon the technology available, it can provide the internet access, but in a limited region. It is mostly used in offices, homes and campus environments. In fact, nowadays there is a trend in all educational institutes that and we boast of also that our institute is Wi-Fi. So, that is the use of this IEEE 802.11 family, and mostly it is used for internet access. So, I have told you initially that the user wants two type of services, one is telephony and another is internet access, and these two basic services he wants just with the help of a single terminal. So, you have to design, you have to evolve a network where internet access as well as telephony both are embedded. The second class of these networks is wireless metropolitan area network, which covers the entire city. Third one, wireless wide area networks, like the example is satellite systems, which can cover large area even at national level they can cover. One more standard is also there in this widest coverage, that is known as IEEE 802.20. So, this is the classification of the wireless networks. Let us see the capability of these networks. We have to keep in mind that we need two things, one is high data rate and second mobility support. If we look the capability of the existing wireless networks, we find that they do provide the data rate, but that is limited. However, mobility support is available, and but mobility support is also, it is not ubiquitous in nature. If you put like the Wi-Fi access points in your institute, then internet will be available in only within the range of that access point. But anyhow, within that area you can move around and you can access the internet. And in this wireless networks, as I already told, that wireless LAN or Wi-Fi is the most successful wireless technology. To see the strengths, I think you all have studied the data networks or computer networks paper. So, you might be aware of all these facts. Anyhow, I am again repeating it for your reference. 802.11 family does not involve much cost, as I have just told you. If internet access is available at certain point, then you can have the access point at any proper location, and then you can access the internet. Deployment is also easy. Even our technicians or system attendant, they can do this part. Availability of products. See, in order to make any technology pervasive, it is necessary that this technology is available. A very good example is that initially the telephony services was provided only by this Department of Telematics. So, there were limited users. Once you open it, then there are so many users. So, it means that now service is available, product is available. So, as far as 802.11 family is concerned, there are so many vendors available. So, products are available. Once the product is available from different vendors, the cost is bound to come down, and hence the people can afford more and more services. So, it is a big feature of this standard, and this is, when I say standard, it means there is somebody who has given some test specifications, and anybody manufacturing those products must meet those requirements, and then it can come in the market. Another feature or strength of this product is that we use it in unlicensed radio spectrum. The deployment of this technology does not require the approval of the government body. So, it makes the deployment very easy, it is hassle free. Reduced prices, I am again coming, because the market is quite open. So, there are so many vendors available. I have given you Netgear, D-Link, Cisco, Avaya. There are so many players available in the market, and they have the competition also. So, the prices are going down. Client network interfaces are interoperable. Client network interfaces means, say, when we design the interface either for mobile phone or for this laptop, again this is a standard. The meaning of a standard is that we have 3 standards in TV. So, if when we manufacture the TV, then we have to follow all those standards, all those specifications, and that they are interoperable. So, same thing applies here, that client network interfaces, they are interoperable. Then roaming is also possible. Roaming, as you know, that when we go from the area to which we have subscribed to the area which we have not subscribed to, then even then I want to access the information in that network. So, if there is an agreement at the technical level as well as the commercial level between the two service providers, then I can access the information, and that is known as roaming. So, roaming is also possible. And encryption deals with the privacy, that whatever you are talking about, it should be encrypted, no unauthorized user should be available to access this information. And in wireless LAN, you must be knowing that we use wire equivalent privacy and WP and all those. So, these cryptographical algorithms are available as far as extents of this wireless LAN is concerned. But let us see the limitations of this. The first limitation is that range. I told you that we need ubiquitous coverage, and in ubiquitous coverage I do not find any bind on the range. If I am in the market, I want to access the information network, so that may not be covered by the access point. So, that is first limitation. Then bandwidth and data transfer rate, yes, we do have aggregate throughput on the order of 54 Mbps. You people are in MTech communication, you will find that there are two things. One is aggregate raw data rate, which is theoretical value, which I have indicated here 54 Mbps. But this, when we download the contents or when we upload the contents, this is never available because of so many overheads, and it is assumed that the actual throughput which is available, it is around 40% of the raw data rate. So, you can calculate the 40% of this 54 Mbps, that will be the actual throughput available to the user. Anyhow, if you are working in this area, then you can use some additional techniques and we can have 108 Mbps throughput. These products are nowadays available. A very interesting and research area in this wireless LAN is IEEE 802.1n, and this 1n is being designed in such a way that it can offer 540 Mbps. So, remember that this can make a very good alternative as far as broadband wireless access technology is concerned, because it does provide a very good bandwidth. However, limitation is in terms of range. Performance degradation is there. You know that here the medium is shared among all the users. So, in that case, when there are so many users, the performance is bound to degrade. Power consumption is fairly high. See, when we are using portable devices, mobile devices, we are always scared about the battery. So, if I am using laptop in wireless communication, then battery is of 3 to 4 hours. After that, I have to charge it. So, that is a problem. And there are some algorithms by virtue of which you can minimize the power consumption, maximize the battery life. Limited range, as I have already told you. Further limitation, contention based probabilistic access to wireless channel. You can do the project on this area, that here when we want to access the media, then it is a contention based. There are two types, one is polling, another is contention based, that you are ready to transfer data, someone is also ready to transfer the data, there will be contention. If you find the media free, you can transfer the data, otherwise you wait for, and then after that again you try. So, the medium access is probabilistic, it is not certain. Of course, wireless channel is there, and in case of wireless channel, all sorts of fadings are always available. So, the quality cannot be ensured, whereas sometimes the fading can be of 40 dB. So, at that time I may not have the signal strength, the data transfer rate will be quite low. But again, if say fading is not there at any particular moment of time, I can have very good signal strength, we can have very good transfer rate. So, but this is out of our control. Okay. So, the fading phenomena is there, and that is why it provides the variable link quality. So, this is again a limitation of this network. Let us come to the motivation for broadband wireless access technology. So, ultimately the result is that the user or we people are not satisfied with the power of the current technology in terms of coverage, in terms of mobility, as well as in terms of high data transfer rate. These are the basic requirements, and all the technology we have discussed now, they have some or the other limitations. They say that this is the mantra of communication technology nowadays: make all types of informations available anywhere, anytime, but at low cost. To provide wireless services comparable to wireline network for fixed and mobile users. The answer is broadband wireless access technologies, and one family member in this broadband wireless access technology is WiMAX. In addition to WiMAX, there are some other technologies also, but I will concentrate on WiMAX because it is the most mature technology till date as compared to others. What is WiMAX? WiMAX stands for Worldwide Interoperability for Microwave Access. This is the full form of WiMAX. It is the commercialization of IEEE 802.16 standard. As you know that when I recognize these IEEE 802.16 means this is a working group, and that has been assigned a task that you prepare the specification, you design this technology and then give the name of some standard name. So, this is a working group that is working towards the that is the development of a WiMAX. Other standards are also being developed. One is from ETSI, European Telecommunication Standard Institute. One more is there from TTA, that is Telecommunication Technology Association. Ultimately, WiMAX is the technology for wireless broadband access and being developed upon IEEE 802.16 framework standard. You can say that this is the logical successor to 802.11. It will provide the connectivity at all times, at all places, at affordable costs. What does it offer? See, when I say what does it offer, you have to keep in mind that what 802.11 has offered, and then we shall compare it to, so that all those limitations which I identified over there should be overcome by WiMAX. Then and only then WiMAX can overcome, then and only then it can supersede those. See, it is interesting that WiMAX can offer the data rate up to 134 Mbps, though it depends upon assigned bandwidth, because there is a relationship between data transfer rate and bandwidth, C is equal to B log 2. So, bandwidth is again adaptation, it is based on adaptation. I can provide more bandwidth, so the data transfer rate can be more. Anyhow, on the average it can provide up to 134 Mbps and average throughput 75 to 100 Mbps. Metropolitan area technology means it can cover the entire city. So, it means WiMAX falls under WMAN. Typical cell size can be 7 to 10 kilometer, it can be though up to 50 kilometer, but as you know that if you increase the power, it has some other problems. Range you can increase, but the data transfer rate will decrease, because as you move away signal strength will come down and hence the data transfer. It does provide the mobility to fixed users, portable users and mobile users. Scalability is also there. As I just told you that bandwidth which we give to a user is on the order of 1.5 to 28 megahertz. Now, you should compare the bandwidth vis-a-vis GSM and CDMA. GSM is the standard which we are using for our mobile telephony. Here the channel which is assigned to a particular user is only of 200 kilohertz. CDMA it is giving, do you remember, 1.25 megahertz. WCDMA we are giving 5 megahertz. Here we are giving 1.5 to 28 megahertz. So, quite large band we are offering to the user. So, he can enjoy any type of service. You know that when we want video we need more bandwidth. If you want to enjoy some clips on the information network, you need wider bandwidth. Okay. So, this does provide large bandwidth and hence the wonderful experience a user can have. Quality of service, differentiated services, cost, license free. I think I should move because it is somewhat advanced. Basic architecture is a general question that now you will raise. How does it look like? What are the various components in a WiMAX? You can always compare it with the cellular standard. It is again a cell based technology in which we have a base station. It is I will show that diagram next. Then we have a subscriber station, subscriber terminal. Let me show this one. This is the basic layout. On one hand, let us start with this is public telephone network. Here internet service provider may be there, switching center is there. You start with the base station. This base station is something like a tower we do have in case of our mobile telephony. This base station is having an antenna. This antenna is making an interface with another antenna which is erected on the office building or residential subscriber. Okay. And then in the coverage region of this antenna, which we are calling it as subscriber, let me go further. We are having base station and ST, that is subscriber terminal, and SS, that is subscriber station. So, we have base station, then this antenna is having a subscriber station, and subscriber station will be feeding to all the users within this coverage region. The terminal which is kept by the user is known as subscriber terminal. So, we have three things: one is base station, which is a tower, another is subscriber station, and third is subscriber terminal. Subscriber terminal is like this laptop. So, it is with me, so that will be termed as subscriber terminal. In case there must be some antenna which will be connected to the base station, so that between that box and antenna is termed as subscriber station. So, there are three main components in WiMAX structure: base station, subscriber station, and subscriber terminal. The same thing I have written here. The subscriber station consists of a receiver, antenna, and standalone box. Subscriber terminal, it is a card. Nowadays laptops are fitted with WiMAX cards. Similarly, if you want to operate it on Wi-Fi, then wireless card should be available with this. Okay, it is somewhat like network card. So, network card is for wired networks, wireless cards are for wireless networks. Then these PCMCIA cards are available, and they sit as far as the subscriber terminal is concerned. Then in a structure you also need to have the link budget. Link budget means you want to cover a certain range. Here is the transmitter, on the other hand we have the receiver. So, the signal strength decreases with respect to distance. So, you know that this is the farthest point. So, at least enough power should be transmitted so that it can reach the farthest points. That is known as link budget. Again, originally this WiMAX was designed for high frequency range starting from 10 gigahertz to 66 gigahertz. At high frequency, only line of sight propagation is possible. It cannot go around obstacles, but later on it was felt that because it is not always possible to have LOS communication, particularly in cities. In cities there is hardly any line of sight communication. So, there may be vegetation, there may be skyscrapers, high rise buildings. So, we need to provide an LOS propagation. So, later on some lower frequencies were also incorporated, and those could provide an LOS propagation. Topologies. Topologies, as in case of wired networks we have star topology, ring topology, and so on. Same thing here, we have two important types of topologies in WiMAX. First is point to multi-point. It is the same thing like an access point. You put one access point and then all the wireless LAN users. So, it becomes a point to multi-point communication. So, here base station covers a certain geographical area. All base stations are connected to the fixed backbone network. They distribute the traffic to many subscriber stations. Another is mesh topology. In case of mesh topology, the idea is something like ad hoc networks. I will give you this diagram. This will explain what the mesh topology is all about. Let us start with the radio tower. Radio tower is something a base station. From this base station, let us see the upper one, residential campus. It is having 3 houses. At this house I can have a subscriber station. So, there is a direct communication possible between this radio tower and this one. Okay. So here LOS is possible. Then there is no need of mesh topology. You come at the lowest part. And the lowest part I am having 2 houses, and then in the middle of these 2 I am having another campus having 2 houses. This you see that due to the vegetation between base station and this region, LOS is not possible. So, they may not access the information network. The idea is that okay, let us have we have the connectivity to this area, and whatever subscriber station you have installed here, it will also act as a router, and router can relay the traffic further. So, whatever information you are accessing here, that again can be relayed to this portion. This is known as mesh topology. Is it clear? So, the biggest advantage of the mesh topology is that in case of NLOS you can make the communication possible, otherwise you require LOS. But if every subscriber station is also relaying the traffic further rather than distributing it just to the users, it can again relay the traffic to another subscriber station, and then subscriber station will distribute the traffic to the user. So, this is one important technology which WiMAX can support. As far as standard is concerned, when I speak standard, it means I have to specify the physical layers as well as media access control layer. The frequency range I have told you 10 to 66 gigahertz, but it does provide the LOS communication only. But for wider channels we do the 10 megahertz. Otherwise, I told you that the bandwidth spacing for a single user varies from 1.5 to 28 megahertz. So, typically you can say 10 megahertz channel is provided to the user. Ease of multipath, very high capacity links, licensed as well as unlicensed bands, both the frequency range in both these spectrum is available for WiMAX. Data rate for LOS environment, it does provide up to 135 Mbps and LOS case 75 Mbps. WiMAX forum says that maximum throughput we can obtain from this is 15 Mbps per sector for 3.5 megahertz channel bandwidth, and for 10 megahertz channel bandwidth 35 Mbps data transfer rate can be obtained. If we can use adjacent channels, then we can increase this data transfer rate up to 350 Mbps. We can further decrease the interference and increase the capacity link by sectorized antenna. You can always compare this with cell based technology. In our all mobile standards you will find sectorized antenna. There is no omnidirectional antenna. We have 3 sectors 120 degree each. The advantage of that is, what is the advantage of that? In all the towers we have sectored antennas. The 360 degree is split into 3 sectors, and one antenna is covering 120 degree. The advantage of that is that rest of the 120 degrees, all those users will not interfere with this user, and hence the interference is reduced to a large extent by sectorized antenna. So, same thing we can do here, we can, because it is the tower is something like cellular standard. So, we can use the sectorized antenna and further improve the bandwidth. Yes, I don't know, you know OFDM. Nowadays all the wireless communication technology is based on OFDM. It is a modulation technique and it is wonderful to work with. And in one go, if somebody asks how does this WiMAX provide such high data transfer rate, the one answer will lie in OFDM, orthogonal frequency division multiplexing. It is a multi-carrier modulation technology. Available spectrum here, the idea is, see, in wireless communication the problem is from interference and delay spread. So, in this technology we split the entire spectrum. Let us say we have, this is the entire spectrum. This entire spectrum can be split into n sub channels like this, and then these are known as sub carriers. These sub carriers will be required to carry the traffic. Traffic here is the message or information which the user wants. So, we have the spectrum which we have assigned to the user like 10 megas, and so it is split into a number of sub channels. So, when I split this into a number of sub channels, it means for a particular carrier the bandwidth is reduced. Bandwidth becomes, let us say it is 10 megas, n is 10. So, one carrier will become only of 1 megas. So, the repercussion of this reducing the bandwidth will be that the data transfer rate will be low. Now, what will be its advantage? When the data transfer rate is low, the delay spread is always measured in terms of the bit duration. When data transfer rate is low, bit duration is more, and hence the delay spread as compared to this bit duration becomes less, and once it is less, then interference is reduced. This is the funda of OFDM, because wireless communication is limited by multipath fading. So, it becomes resistant to multipath feeding and delay spread. Okay. So, that is why the such a high data transfer rate we can avail in WiMAX, the credit to a large extent goes to OFDM. The same thing I have written here is robust as far as interference is concerned. These are the standards 802.16, it uses wireless MAN, single physical layer, then NLS case 802.16 2004, this version was released and published in December 2004, that is why the name. It has 3 layers, single carrier and 2 physical layers, channel bandwidth 20, 25, 28 megahertz. Again LOS provide the raw data rate up to 36 to 135 NLOS, which I am repeating again. This is again a very good area where you can start with. If you want to increase the capacity of WiMAX, you can pick up this MAMO, multiple MAMO, this is the advanced antenna technology and modulation. So, we can increase the capacity to a large extent by having adaptive modulation and smart antenna. So, after going through the various aspects and comparison with the existing technology, let us characterize these. WiMAX is a broadband technology because it does provide the throughput on the order of 135 Mbps. So, it allows multiple broad frequency ranges. It has direct LOS and as well as NLOS. So, if a 75 Mbps is available on both links, it can support image, video and data. So, if you go to the triple play service, video, audio and data, it is sufficient to carry all the traffic. 100 megahertz per operator is required for, see again we are talking about the various generations. So, I have given here 3 generations 1G, 2G, 3G, but now we are talking about 4G. In case of 4G, we expect that the standard must support multimedia applications, and for multimedia applications bandwidth requirement is higher, quite higher. In case of WiMAX, but here there is a question, why do not we give much bandwidth to the service providers at the existing band? Like GSM, they are asking for more bandwidth so that they can accommodate more users. CDMA players like Reliance is providing the cellular service in CDMA. So, they are also asking for more bandwidth, but government is not giving or is not fair as far as they state. The problem is that at lower band, the entire band is already crowded. So, where from you will give the bandwidth? If you go at higher band in the spectrum, you know that spectrum starts from 0 hertz, which is DC, up to 10 to power 28 hertz. In between somewhere we are using 10 gigahertz up to 66 gigahertz, and of course there are some lower frequencies also which we are using, as I have shown here, for 2 physical layers. So, at this range the spectrum is relatively available, but if you look the cellular services which we are providing at 900 megahertz or 1800 and 1900 megahertz, over there spectrum is already crowded. Secondly, if you allow the operators to use high frequency band, then you take just 2% of the carrier frequency, it will be more. If you take 2% of 1 megahertz, otherwise if you take 2% of 1 gigahertz, the 2% of 1 gigahertz will be 1000 times more. Okay. So, this is how the larger bandwidth can be provided to a single operator, and it will be, there will be 2 advantages of this. The one, that in the same bandwidth he can accommodate more number of users. Secondly, nowadays multimedia applications are bandwidth intensive, isn't it? When I want to do the video conferencing, it means it requires at least minimum bandwidth requirement should be available to him, to the party always. So, that bandwidth can be available only when the service provider has the bandwidth. So, this is here we can give a single operator 100 megahertz bandwidth. In GSM we do provide like 25 megahertz plus 25 megahertz, 100 megahertz per operator. So, he can give all the services which are asked by the user. So, as such it is a suitable technology for 4G. Lower cost, because the chipsets of PCs are available nowadays, base stations, common platforms bring mobility, uninterrupted access, roaming is possible, convergence is also possible. It is spectrally efficient. For all communication engineers, you must know what is spectrum efficiency. The basic idea of spectrum efficiency is that I have one cycle, 1 hertz, how many bits it can transmit per second, that is the spectrum efficiency. So, in this case it can squeeze 3 bits per hertz per second. So, it is spectrally efficient. Is cost effective. Cost is always seen in terms of how much traffic it can carry per hertz. So, it is carrying 3 bits per hertz. So, it is cost effective. Wide coverage, as I told you, up to 50 kilometer it can cover. Harmonization, yes, because nowadays in world there are so many networks. So, if you want to realize the dream of a real global village, then there will be a seamless communication across all access technologies. So, because its name is already interoperability, it means we are designing the system in such a way that all the different patches of networks can be harmonized. We can it will be transparent to the user, irrespective of what is the underlying technology. User can access the information anywhere, irrespective of the underlying technology. Public key infrastructure authentications are there, highly scalable network, viability of WiMAX as an alternative to 3G. You can compare it with UMTS, WCDMA and evolution data only. Their market penetration is not so encouraging till date. If you read some newspapers or IEEE papers, you will find that yes, they are available to some extent, but that technology has not been accepted as such. So, WiMAX can be an alternative, can be a viability as an alternative to 3G and higher. You can compare the data speed. WCDMA provides 100 kbps, evolution data 2.4, HSDP 8 to 10, WiMAX even up to several kilometers from this 500 kbps. Coverage area you can compare 50 kilometer, spectrally efficient, interference is quite less. Yes, IP connectivity. See, you all know that the next architecture is all IP based. Circuit switching, message switching, it is going to be over. Everything will be converted into packets, whether it is voice, image or data. So, the backbone is IP based. This technology does support IP connectivity, and whatever is the transport technology, whether it is ATM, IPv4, IPv6, Ethernet or virtual LAN, irrespective of that, at the network layer it deals with packets, and that is why it is so viable as far as next generation networks are concerned. Architecture I have already told you. Cost of development is cheaper, backhaul connection to cellular services. Standardization is again an advantage because multiple vendor solutions are coming in the market. Economies of scale, mass production. If there are so many vendors, then mass production will reduce the prices. Research and development, yes, there are so many industries working on this in collaboration with the universities. This is SWOT analysis. See, this is interesting. I will take few minutes here. SWOT, you know that it deals with the strength, weakness and opportunity. If there is a question which technology will survive the market, so you can compare these three technologies. Wireless, and I told you lot, because wireless LAN is the most widely deployed technology. So, I need to compare 3G again is a cellular standard and then WiMAX. You will find that in wireless a high capacity under large bandwidth, but coverage is small. It has the opportunity that supplementary access methods can be used, like I have told you that 802.11n can provide up to 540 Mbps. So, there are some access methods which can improve the data transfer rate, but it is getting threats from 3G and ADSL. 3G networks, yes, they have the strength in terms of data and speech under high mobility environment, high capacity, but their weakness is that bandwidth is small. And yes, market demand is there for the variety of services, and they are being designed to meet the requirements of anywhere, anytime connectivity. But again, it is getting the threat from wireless LAN, VoIP and WiMAX. Finally, WiMAX, it does provide the large coverage, does provide the high capacity, unified standards, but it is immature because it is still under evolution and people are working on this. Interoperability is possible, that you can work upon. Threads are from ADSL, cable fiber and others. Well, let me give the brief account of the typical areas of application. Initially, I told you that nowadays demand is from rural areas. So, you explore the technology which can meet the requirement of rural area. Even our previous president APJ Kalam, he was very fond of the technologies which can be used by the common people rather than the people sitting in air conditioned room. So, saying you explore the technology which a common people, a rural village can use. This technology is very viable as far as rural areas are concerned, because in rural areas nobody would like to lay down the OFC. OFC is good enough when number of users are large, so that they can earn the revenue. If there are 2 or 3 users in a village, nobody would like to lay down the network. WiMAX does provide a solution for such type of environments. I will give you one slide over that. In addition to that, small and medium businesses, a hotspot backhaul it can provide, mobile devices it can be connected to, it can be used for interconnecting base stations. IPTV also, if somebody is using TV, then for IPTV means here the TV content is delivered in terms of IP. First one was SDTV, standard definition TV, then came high definition TV, the third TV is IPTV, internet protocol TV. For IPTV, WiMAX is the most suitable technology. So, you can explore this area. Access network I want to show here. The idea is that how this technology can be used for providing the connectivity to rural areas. Say, let us say place you have the GPRS network. I have taken the GPRS network because it can provide the data service. GSM does not provide the data service, so GPRS. GPRS has two interfaces, BTS and BSC. These are the parts of the tower. Okay. After the tower, I have used a subscriber station. Here I told you that in WiMAX, it can have the maximum range up to 50 kilometer. So, in villages, the number of users are less and they are far apart. So, let us say in a particular village there is a residence of Pradhan. So, at Pradhan's residence you need the internet connectivity somehow. So, you have one user. In the nearby village you can have one more point. So, we can have one subscriber stations in this village on another subscriber station at other place. And of course, you need to connect to the backbone also. So, you can connect to the backbone because one subscriber station can cover up to 50 kilometer and so. So, as such you do not need to put so many stations, a few stations will be sufficient to cover the large area. So, here the advantage is that you can have a very large area as far as WiMAX is concerned. So, this is how the WiMAX can be a very useful technology for providing the connectivity to the rural areas. No other technology can provide this. Evolution, there are various standards of the WiMAX technologies. The first is 802.16, it is used for fixed users. Then nowadays we are moving towards 802.16D, 802.16E, which is providing the mobile connectivity also. This is 802.16, this is for mobile WiMAX and it was released in September 2005. Current state of the art, there are so many patents available, 330. I mean to say that the work is going on. Even Motorola has come up with Y4, Fujitsu has also come up with a product. In Indian context, there are certain cities which are rigged up on WiMAX. Pune is having WiMAX. Even in Haryana, BSNL is planning to have 10 cities on WiMAX. This is a pilot project and let us see how much they are successful, because it has certain problems with mobility till date. So, they want to lay down the network and see what are the problems. So, BSNL is doing some similarly MTNL is going in Delhi and Mumbai. This 802 is another broadband access technology which was released in 2002. It does provide the mobility support up to 250 kilometer. We can compare 802.20 with 802.16. The advantage of 802.20 is very high speed, vehicular like trains and all those, 250 kilometer per hour. But in that case the bandwidth will not be so much high. 802. This is again wireless regional area network. Next generation satellite networks, they are also covered under broadband wireless access technologies. HAP is again lower orbit satellite communication system which can give the connectivity to the rural areas. But ultimately the result is that the future network will be a combination of WiMAX and Wi-Fi. We need to integrate the architecture as well as quality of service mechanism. Which technology is better? You can always compare in terms of the ubiquitous nature, data rate and mobility support. Here is I have prepared the slide that if you increase the coverage, the data transfer speed will come down. If you increase the data transfer speed, then coverage will be less. So, you have to make a compromise. What do you want? WiMAX is cheaper. In order to conclude, most promising technology for broadband wireless access over the metro. It can handle digital IP media, so it can be a viable solution for 4G, key enabling technology for 4G. Challenges are full mobility. It is a research problem that in order to provide the handover from one terminal, one substation to another substation, you need the handover mechanism, interoperability, test specifications being evolved. Frequency band, see when I say that the lower 10 gigahertz frequencies can also be used, but those frequencies are already allocated by the government to others. So, if you want to use those frequencies, then reallocation has to be done. So, this is just again a political decision that government has to take. Short term limitations, still we do not know who will be the service provider. BSNL is being the government body, so it can go ahead with that, but other private players, we do not know how the license will be given to those. Availability of equipments, yes, there are some equipments like PCMCIA cards which can fit into the laptop, but still they are in trial stage, and we expect that those will be available in 2007 and next 2018 market in full swing. Solution to this of course will shape the future development, and surely once the WiMAX is available, the wireless world of 4 zones we shall be living in. We are moving towards the mobile information society once all these concepts could be realized technically, and we can say that we shall be living in the wireless world. That is all from my side. Now it is open for discussion.